Evil cannot create. Only the story what is good. All the world be great.
Don't let the fear steal your peace, no. Don't let the fear steal your peace.
Hey, Christina Pekas here. Just wanted to hop on real quick and do a little math. I know, scary, huh? Not really. There's a little geometry problem with how if you are using a projector to cut out your patterns, and your throw distance isn't long enough because you have a table and your ceiling's not so high, and you don't have an alternate short throw projector, and you want to use a mirror to extend the throw length. How do you calculate what size mirror you need? So let's get started. Okay, so we'll see how this works with a piece of paper. I was told that you couldn't really see, something was too small earlier. If that doesn't work, try with a whiteboard later or something like that. Okay, so what do we know? We were given that she has a table, okay, and she has a projector up here. And this distance, she originally said 60. It turned out later it was actually slightly shorter, but we're going to go with 60 right now. And she needed more than that. Okay, so what we also know is she looked in the specifications on Amazon for her projector, and the shortest distance that they recommend was 3.7 feet. And at 3.7 feet, the diagonal of the image is 35 inches, okay? So another question is, what size will it be here on the table? But let's, first things first here. So 3.7 feet, it's kind of weird to have a decimal feet, but there we are, is about 44.4 inches. Okay. And all right, so she's going to put the projector on the ceiling. She's going to put the mirror here. And then so the light is going to come out and then go down, right? Ugh, sorry. It's supposed to be a good triangle. Okay, so this is just a triangle, right? Just going to bounce. And you can, she can move this to move where she wanted it. Right? So instead of having the throw distance, and I think, okay, so if you have a projector, right? And you have where it's projecting to. So it goes like this, right? So if you move the screen up here, you can see that this distance is shorter. And as you move the screen back, it gets, it gets bigger. Now there's like a limit, right? Because how bright your light bulb is. Whether it can actually make it out here. And there's also like focusing problems too if you get too close. Anywho, okay, so she needs to go, instead of going here, she goes the hypotenuse, right? Because the hypotenuse of this triangle is going to be longer. So we know this side of the triangle is 60. We know this is 44.4. So we can see what this distance here is going to be, right? Okay, we also know, okay, so what, the easiest question, right, the first question is, what size mirror do you need, right? So this distance here is going to be 44. What size mirror is that? Well, we know it's 35 across, but that's awkward when you're actually buying a mirror because what you need are the length and the width. So we know that, a squared plus b squared equals c squared, right? And we have c squared is, 35 squared, right? And we have, so we have a plus b. Right, so we know that most of these projectors are like a 4:3 to 3 ratio. So I went with that, assuming that's what it is. If that's wrong, we'll just do something else. So then that would be like 4x squared plus 3x, I'm running out of room, squared is 35, right? So what you can do is 16x squared plus 9x squared. You can't see where I'm going here? Equals 35 squared. So 35 squared divided by 25 squared and then square root. Anyway, so we know that x equals 7, right? So we need 28 by 21 for the mirror size. Frustratingly, the second half of my recording got lost, but here we are with a lovely mock-up. Okay, so we know what size the mirror needs to be if it's that distance away. So what we need to know is the final throw length, and then to use that to calculate the what the final size will be on the paper, or at least to approximate it, let's say. So let's see if I can type on here. Okay, so right now we have we know that instead of the light going straight down, which is 60, it's going to go 44, and then whatever the hypotenuse is. So the hypotenuse is 44 squared, right? Plus 60 squared, and then take the square root of that. Right? Okay, so we have an x squared button here, nice. And then we have a square root. So 74.4 is the other distance, right? So instead of the light traveling 60, it's going to go 44.4, or 44 plus 74.4. So, okay, it's going to go 118.4. So, okay. So we know that we have like two triangles that have the same angle. So, you could do the tangent and say opposite over adjacent is the angle, and then given the adjacent, find the opposite. But you can also just do a ratio. So you can say that, let's see, 21 is to 44 as what is to the new distance, right? So let's get our calculator back up. Let's clear it. So 21 divided by 44 is, okay, and times, okay, so 56. So 56 is going to be like the shorter distance. So that's 3/4 of what the total distance, what the other side is going to be. So you can get your total area. Clear as mud, right? Thanks for watching. Sorry for the confusion. I hope this helps at all.
Evil cannot create. Only the story what is good. All the world be great.
Don't let the fear steal your peace, no. Don't let the fear steal your peace.